Hello everyone, welcome to my channel. Today in this video I will discuss about a voltage divider with some basic trick. So let's get started. So the voltage divider gives the half of the input voltage with two equal value of resistors at the middle. So as you can see here, the input voltage is 1 volt, output voltage is 0.5 volt. So because the R1 and R2 are equal, R1 1k and R2 1k, so that's why we are getting the half of the input voltage. So this is the voltage divider. So here we are losing half across this resistor and we are getting the remaining half voltage at output side. Okay, so next I am considering the R1 and R2 with different value. R1 and R2 are not same value, so and the output also will not be the half of the input voltage because of the R1 and R2 are not equal. So now we will calculate what will be the output voltage. So this is the formula: V out equal to V in into R2 divided by R2 plus R1. So we are using this formula because the R1 and R2 are not equal. Okay, so what is the V in? V in is 1 volt and R2 is 30 ohm. R2 plus R1, 30 plus 70, so 30 plus 70 will be 100, and ohm and ohm cancel, so 30 divided by 100 equal to 0.3, so 0.3 into 1 will be 0.3 volt. You can calculate, then we will be getting 0.3 volt. Okay, so next here I am considering the R1 is 30 ohm and R2 is 70 ohm. My input voltage is 1 volt. Okay, so apply the formula V out equal to V in into R2 divided by R1 R2 plus R1. So after calculation the output will be 0.7 volt. Okay, the next here I am considering my input voltage is 5 volt and R1 is 2 mega ohm, R2 is 6 mega ohm. So R1 and R2 are not equal. So now we can apply the formula. So what is the V in here? V in 5 volt and R2 is 6 mega ohm. R2 plus R1 6 mega ohm plus 2 mega ohm. 6 plus 2 will be 8. So mega ohm cancel. Now 6 divided by 8. So after calculation you will get this, you will get the 3.75 volt. Okay, so next here my input voltage is 6 volt and I need output 2 volt, but I don't know the R1 and R2. So in this circuit we have to calculate the R1 and R2 value because my input voltage is there 6 volt, I need 2 volt. So how to find the R1 and R2? So if you see here, input is 6 volt, output is 2 volt. So that means we are losing 4 volt across this resistor and we are going to lose 2 volt across this resistor. So here 4, here 2. Okay, so 4 is to 2. So if you divide it by 2, it will be 2 is to 1. 2 is to 1 same as 4 is to 2. I repeat, I need 2 volt at output side, but I don't know the R1 and R2. We have to calculate the R1 and R2 value. So input 6 volt, output 2 volt. So 6 minus 2 equal to 4. That means we are losing 4 volt across this resistor. and we are going to lose this 2 volt across this resistor. So that means 4 is to 2, 4 is to 2, 2 is to 1, same as 4 is to 2. So that means the R1 will be the twice of the R2. 2 is to 1 means 2 is R1, 1 is R2. So R1 will be the twice of the R2. So 2K and 1K. So 2K is twice of the R1, R1 is 1K, R2 is 1K, and R1 is 2K. R1 will be the twice of the R2. So now you can put here like 2 ohm, 1 ohm. Okay, so and you can put here 100K and 50K. Okay, so it depends up to you. So if you need very less amount current at your output side, then you can use the higher resistance value. If you need a higher current at output side, then you can use the lower value of resistor. So it depends on your output circuit. It depends what you are going to connect at output. If you are going to connect op-amp circuit at output side, then you can use the higher value of resistor, because op-amp no need much more current. Okay. So next, the input voltage is 10 volt and I need output 2 volt. Now we'll calculate what is the R1 and R2. So here 10 volt, here 2 volt. So we are losing 8 volt across this resistor, and we are going to lose 2 volt across this resistor. So 8 is to 2, 8 is to 2. If we divide by 2, it will be 4 is to 1. So that means R1 will be the 4 times of R2. Okay, so 40K and 10K. 40K is 4 times of R2. Okay, so it depends up to you how much resistor you are going to use, and keep in mind that R1 will be the 4 times of the R1. Okay, so next, the input voltage is 15 volt and I need output 9 volt. Now we will calculate what is the R1 and R2. Look here, input is 15 volt, output is 9 volt. So 15 minus 9 equal to 6. So that means we are losing 6 volt across this resistor, and we are going to lose remaining 9 volt across this resistor. So that means we can write 6 is to 9. 6 is to 9. If you divide by 3, it will be 2 is to 3. So that means the R1 will be the 2K and the R2 will be the 3K. Okay. So now we'll calculate the power dissipation of this circuit. Okay. So the input voltage is 5 volt, R1 is 70 ohm, R2 is 30 ohm. Now we'll calculate what is the power dissipation of this circuit. This is the formula. Power dissipation equal to V in square divided by R1 plus R2. What is the V in? 5 square divided by 70 plus 30. 70 plus 30. 70 plus 30 will be 100. So 5 square means 25. So 25 divided by 100, it will be 0.25 watt. So that means the power dissipation of the circuit is 0.25 watt, and we have to use the resistor wattage more than 0.25 watt. We cannot use less than this wattage. Okay, thank you.